Hello and welcome to Selection with Sathi. Today we dive into operator overloading from Fluent Python Chapter 16. We'll learn how to make custom objects support plus, minus, times, comparison operators, and the matrix multiply at operator. This is a powerful way to write expressive, Pythonic code. Unary operators are the simplest to overload. Minus x calls x dot underscore underscore negative underscore underscore and should return a negated copy. Plus x calls x dot underscore underscore pos underscore underscore and usually returns a copy. Abs of x calls x dot underscore underscore abs underscore underscore and returns the magnitude. The key rule: always return a new object. Never modify self. For binary operators like plus and times, a plus b first tries a dot underscore underscore add underscore underscore b. Your underscore underscore add underscore underscore method must return a new object, never modify self. If the types don't match, return not implemented. That's the singleton, not the exception. The same pattern applies to underscore underscore sub underscore 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 truediv underscore 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 floordiv underscore underscore and underscore underscore mod underscore underscore. Reflected operators handle the case when the left operand doesn't know the right type. If a dot underscore underscore add underscore underscore b returns not implemented, Python tries b dot underscore underscore radd underscore underscore a. This is essential for mixed type operations. For example, 3 plus vector can't work through int dot underscore underscore add underscore underscore, so Python calls vector dot underscore underscore radd underscore underscore 3 instead. Same pattern underscore underscore r sub underscore 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 armal underscore 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 truediv underscore underscore. Augmented assignment operators like plus equals behave differently for mutables and immutables. For mutable types like lists, underscore underscore add underscore underscore modifies self in place and returns self. For immutable types like tuples, there is no underscore underscore add underscore underscore, so plus equals falls back to underscore underscore add underscore underscore and rebinds the variable. If you define underscore underscore add underscore underscore, always return self after modifying. Python has 6 comparison operators, each with its own dunder method. Underscore underscore ik underscore underscore for equals, underscore underscore lt underscore underscore for less than, underscore underscore gt underscore underscore for greater than, underscore underscore l underscore underscore for less or equal, underscore underscore g underscore underscore for greater or equal, and underscore underscore n underscore underscore for not equal. Writing all 6 is tedious, so use @functools.total underscore ordering. Define just underscore underscore ik underscore underscore and one of underscore underscore lt underscore underscore or underscore underscore gt underscore underscore, and the decorator generates the rest.
Let's add two vectors using the plus operator. Our vector class stores x and y, underscore underscore add underscore underscore creates a new vector by adding corresponding coordinates. v1 equals vector 2, 4, v2 equals vector 2, 1. v1 plus v2 gives vector 4, 5. The original vectors are unchanged, a new object is returned. For scalar multiplication, we need both underscore underscore mul underscore underscore and underscore underscore armal underscore underscore. Underscore underscore mul underscore underscore handles v times 3, multiply each component by the scalar. Underscore underscore armal underscore underscore handles 3 times v. It just calls self times scalar. Without ________, writing 3 times we would fail with a type error because int.____mul__ doesn't know about vector. Both we times 3 and 3 times we now return vector 3, 6. Python 3.5 introduced the @ operator for matrix multiplication, PEP 465. We implement ___matmul__ for the dot product of two vectors. It returns self.x times other.x plus self.y times other.y. V1 equals vector 1, 2, V2 equals vector 3, 4. V1 at V2 gives 1 times 3 plus 2 times 4 equals 11. NumPy uses this heavily for matrix operations. For sorting, we need comparison operators. Instead of writing all 6, we use @total_ordering from functools. We define __ek__ to compare coordinates and ___lt__ to compare magnitudes. The decorator autogenerates ___len__, ___gt__, and ___g__. Now sorted of a list of vectors works perfectly. All 6 comparison operators from just 2 method definitions.
Key tips to remember. Always return not implemented the singleton. Never raise not implemented error the exception. Operators should return new objects. Never mutate self in ___add___ or ___mul__. Implement ___armul___ whenever you define ___mul___ so Scalar times object works. Use @total_ordering to avoid writing all 6 comparison methods manually. For more concept videos like this, download the Selection with Sathi app. Like and subscribe. Thank you.